Hello everyone, we are Group 10 and will give a simple introduction of HDMI and DVI. More details can be found in our report. HDMI is a standardized protocol for transmitting high-quality digital audio and video signals between devices. The transport is based on the transition-minimized differential signaling protocol. HDMI has 5 types. All 5 types of connectors transmit the necessary HDMI signals, including a TMDS link. The Type B connector is marginally larger and includes a secondary TMDS link, essential for supporting ultra-high resolution displays through a dual-link setup. The Type C connector transmits identical signals as Type A, albeit in a more compact form, suitable for portable devices. Type D connector also conveys the same signals as Type A, but even smaller than Type C. The Type E connector, transmitting the same signals as Type A, is designed for use in automotive applications. All phasors and functions are equally available to all connectors except Type B and Type E. Details can be found in our report. Since its introduction in 2002, HDMI has undergone several updates and version iterations to support new technologies and enhance performance. Here's a brief overview of some key HDMI version changes. HDMI 1.0 was the original version, released in 2002. It supported video resolutions up to 1080p and audio up to 8 channels. Launched in 2009, HDMI 1.4 added support for 4K resolutions at up to 30 frames per second. Additionally, it introduced an audio return channel, allowing TVs to send audio back to an AV receiver without needing an actual audio cable. Released in 2013, HDMI 2.0 increased support for 4K resolutions at 60 frames per second. It also increased the bandwidth capacity for audio and video, supporting up to 32 audio channels. HDMI 2.1 is the latest version and was released at the end of 2017. It significantly increased bandwidth, supporting video resolutions up to 10K and 4K and 8K videos at up to 120 frames per second. HDMI 2.1 also introduced new features such as a high dynamic range and enhanced audio return channel, as well as improved support for gaming features like variable refresh rate. The figure illustrates the conceptual diagram of a TMDS differential pair. TMDS technology employs a current-driven approach to generate the low-voltage differential signal on the sink side of the DC-coupled transmission line. The link's reference voltage, AVCC, establishes the high-voltage state of the differential signal, whereas the low-voltage state is set by the current source of the HDMI source and the termination resistance at the sink. The termination resistance, RT, must align with the characteristic impedance of the cable, Z0. The figure left describes a single-ended differential signal, indicative of either the positive or negative pole of a differential pair. The standard high-level voltage for a signal is AVCC, and the standard low-level voltage is AVCC minus V swing. Given the differential nature of the swing across the pair, the total signal variation on the pair is double that of the single-ended signal, amounting to 2 plus swing. As illustrated in figure right, the differential signal oscillates between positive V-swing and negative V-swing. As for physical layer, it can be seen that HDMI is used for the connection between audiovisual source and sink. HDMI cable buys 3 groups of differential signals to transmit TMDS data, 1 group of differential signals to transmit clock. In addition, HDMI has a channel for DDC to connect to the sink's EDID. CEC and HEAC are both optional protocols for HDMI. This is the most commonly used Type A connector pin assignment. Other types are also detailed in our report. The link architecture of HDMI. An HDMI link includes 3 TMDS data channels and a single TMDS clock channel. The TMDS clock channel constantly runs at a rate proportional to the pixel rate of the transmitted video. During every cycle of the TMDS clock channel, each of the 3 TMDS data channels transmits a 10-bit character. The HDMI link operates in one of 3 modes: video data period, data island period, and control period. During the video data period, the active pixels of an active video line are transmitted. During the data island period, audio and auxiliary data are transmitted using a series of packets. The control period is used when no video, audio, or auxiliary data needs to be transmitted. A control period is required between any 2 periods that are not control periods. Video data periods use transition minimized coding to encode 8 bits per channel, or 24 bits total per pixel. Data island periods are encoded using a similar transition minimized coding, TMDS error reduction coding, TRC4, which transmits 4 bits per channel, or 12 bits total per TMDS clock period. During control periods, 2 bits per channel, or 6 bits total, are encoded per TMDS clock using a transition maximized coding. These 6 bits are HSYNC, VSYNC, CTL0, CTL1, CTL2, and CTL3. Near the end of every control period, a preamble using the CTLX bits indicates whether the next data period is a video data period or a data island period. For control period is used for transmission of the preamble. The control period is also used by the sink for character synchronization. Immediately preceding each video data period or data island period is the preamble. This is a sequence of 8 identical control characters that indicate whether the upcoming data period is a video data period or is a data island. The values of CTL0, 1, 2, and 3 indicate the type of data period that follows. The remaining control signals, HSYNC and VSYNC, may vary during this sequence. There are only 2 legal preamble characters. The video data period type indicates that the following data period contains video data, beginning with a video guideband. The data island type indicates that the following data period is an HDMI component data island, beginning with a data island guideband. The transition from TMDS control characters to guideband characters following this sequence identifies the start of the data period. The data island preamble control code 1010 shall not be transmitted except for correct use during a preamble period. For video data period, video data periods are used to carry the pixels of an active video line. Each video data period is preceded by a preamble, described above. Following the preamble, the video data period begins with a 2-character video leading guideband. There is no trailing guideband for the video data period. During active video period, 24 bits of pixel data are encoded using TMDS transition minimized encoding during each TMDS clock period. Data islands are used to carry packets of audio sample data and auxiliary data. This auxiliary data includes info frames and other data describing the active audio or video stream or describing the source. Each data island is preceded by a preamble, described at the last page. Following the preamble, each island starts with a leading guideband. The first packet of the data island then follows. During every TMDS clock period of the data island, including the guideband, bits 0 and 1 of TMDS channel 0 transmit an encoded form of HSYNC and VSYNC. Bit 2 of TMDS channel 0 is used to transmit the packet header. All 4 bits of TMDS channel 1 and 2 are used for the packet data as shown in the figure left. Each packet is 32 pixels long and is protected by BCH ECC for error correction and detection purpose. During the data island, each of the 3 TMDS channels transmits a series of 10-bit characters encoded from a 4-bit input word using TMDS error reduction coding, TRC4. TRC4 significantly reduces the error rate on the link by choosing only 10-bit codes with high inherent error avoidance. The last 2 characters of the data island, following the last packet, is a trailing guideband. Following the data island, all 3 channels revert to transmitted control characters. The first 2 data characters within the data island are the leading guideband, and the last 2 data characters within the data island are the trailing guideband. During the data island guidebands, channel 0 is encoded as one of the 4 TRC4 values. These TRC4 values are 0xC, 0xD, 0xe, and 0xf, depending upon the values of HSYNC and VSYNC. On the left is the 2 control signals for each of the 3 TMDS channels are encoded. On the right is TMDS error reduction coding, the TRC4, which is used during the data island period to encode 4 bits per channel into the 10 bits serialized and transmitted. This page is video data encoding and decoding and 3-figure encoding algorithm definitions and the encoding algorithm and decoding algorithm. This is a description of the encoding algorithm used during transmission of video data. During video data, where each 10 bits character represents 8 bits of pixel data, the encode process of the active data period can be viewed in 2 stages. The first stage produces a transmission minimized 9-bit code word from the input 8 bits. The second stage produces a 10-bit code word, the finished TMDS character, which will manage the overall DC balance of the transmitted stream of characters. Details are complex, so we only put it in report. Digital Visual Interface is a video display interface developed by the Digital Display Working Group. The digital interface is used to connect a video source, such as a video display controller, to a display device, such as a computer monitor. It was developed with the intention of creating an industry standard for the transfer of uncompressed digital video content. There are 5 kinds of DVI. DVI-D is for digital signals only, good for connecting computers to digital screens. It has 2 versions, a single link for standard quality and dual link for high quality. DVI-A is for analog signals only, used for older devices. DVI-I works with both digital and analog signals, comes in a single link and dual link like DVI-D. Both DVI-D and DVI-I can be dual link, supporting better quality by having more pins. A TMDS transmitter encodes and sequentially sends an input data stream through a TMDS link to a TMDS receiver. The input stream includes both pixel and control data, depends on the status of the data enabled signal, DE. The transmitter includes either the pixel data or control data in each input clock cycle. An active DE signal signifies the transmission of pixel data. It should be noted that when either pixel or control data is being sent, the other is disregarded. Within the TMDS receiver, the transition of recovered pixel or control data is contingent upon the DE being active or inactive. The encoding and decoding algorithms are same as in video data period of HDMI. DVI and HDMI interfaces have several similarities. Both are high-speed data transmission interfaces suitable for transmitting digital high-definition television signals. Both utilize the minimized differential signal transmission technology (TMDS) as a basic structure of the data link and support hot swapping. They also have many differences. Compared with DVI, HDMI has a wider range of uses with higher transmission speeds and supports audio. It can transmit over longer distance and also comes with HDCP copyright protection. These are references. That's all. Thank you.